Hello, Math 7 students. This is Open Up Resources, Unit 2, Lesson 3, more about constant of proportionality. This is the second video in our two-part video series for this lesson. To review some of the things that happened last time, we had a relationship between centimeters and millimeters. And we were able to identify that relationship both ways, whether we're going from centimeters to millimeters, or if I'm going from millimeters to centimeters. We were able to organize that information in a table. And then we were able to look for that relationship, like specifically, how do I go forward in the table? For this first one, we went forward in the table by multiplying by 10, and we realized that that is the constant of proportionality. It's a number that we multiply by. And when I reversed the millimeter and centimeter columns, now as I go forward in the table, I'm multiplying by 1 over 10, or 1/10. So again, we saw that the constant of proportionality is 1/10. That's the number that we multiply by. And the relationship between those two constants of proportionality, 10 and 1/10, they are reciprocals. Those are the key takeaways from what we did last time. And now we're ready for this next problem, which is just a single problem, but it is a challenging problem. So I first want to give you some hints. You're going to notice that we have a table here, and then we have the exact same table down below. Because we are going to be doing this problem twice using different units of measurement. So to keep it simple, I'm going to give you guys some hints going into it. But let's read through the situation. A plane traveling at a constant speed flew over Pittsburgh, St. Louis, Albuquerque, and Phoenix, all on its way from New York to San Diego. You can kind of sort of see the path. The plane went this way, then it kind of jutted down, and it flies over all of those cities. And we are going to complete the table. We can see that from Pittsburgh to St. Louis, it took 1 hour, and the distance was 550 miles. Let's just get this out of the way. Let's find a pattern. All we have is just that one piece of information right now, but we have a 1 here and a 550 there. So tell me this, how does that 1 change to a 550? Quickly talk amongst your tables because not every hand is raised. How does the 1 change to 550? Okay, now come back to me. Let's see those hands now. It's better. That's a lot more hands. How does that 1 change to a 550? Let's go, Cheyenne. Exactly. It's so easy whenever we have a 1 in the table. It's so easy because 1 times the number is the number. So if I'm multiplying and I get 550, I must be multiplying by 550. So what do you think we're going to do here in the table? Any thoughts? Any ideas? Zachary? Why multiply by 10? Okay, I want to review what we did back here though. The 1 times 550 is 550. Should we change our strategy just because we're in a new spot on the table? Probably not. So this strategy worked here. I want to continue to use that strategy. So instead of multiplying by 10, I'm going to multiply by 550. So that means, here's your hints right now. What am I going to do right here? I don't even know what this number is, but what do I do as I go forward in that table every single time? Addie? We will go backwards, but let's pretend like we're going forwards though. If I'm going to go forwards, what would I still want to do? Kate and S? Multiply by 550. But Addie's like, well, we don't have anything here to multiply by. So she knows that what are we going to do? We're going to go backwards and divide. Exactly. You guys got all the hints that you need now. Now, here's the challenge that we have. 1 hour. And here it's 1 hour and 42 minutes. Let's make this easy on ourselves, and let's write this as a decimal. Talk with your groups first. 1 hour, 42 minutes. What is that going to look like as a decimal? Talk to each other. I'll give you 30 seconds to discuss before we talk together as a class. I want 1 hour and 42 minutes written as a decimal. Okay, your time is up. Who's brave enough? Who knows it? Good, lots of hands. Maston. Who has 1.42? Yep, that's what I thought. You're all wrong. No? Good. Okay. I knew that most of you were going to put 1.42 because even the honor students who had this lesson a while ago, they put 1.42. But I want to make sure that you understand why this isn't okay. Put your hands down. I know you want to share the right answer, but I really want to focus on this wrong answer because this is a good mistake to make. We can learn a lot from this mistake. Think about our decimals and our place values. This 4 is in what place value? This is the what's place? Tenths place, and this is in the hundredths place. So 1.42 means 1 and 42 hundredths. Are there 100 minutes in an hour? Nuh-uh. There's only 60. And we can't use decimals to show minutes because minutes, there's 60 in an hour, and decimals show that there would be 100. So this is not going to work out. I'm so grateful that we had someone make that mistake. Let's talk about the right way to do that then. Since there's only 60 minutes in an hour, as I said, this is not right, 1 and 42 hundredths. How would I fix this to make this more correct? Luke? Yeah, instead of 100, it would be 60. It would be 1 and 42 sixtieths. That's a lot easier, right? But now I still want this to be as a decimal. So this is where our calculators are going to come in handy. 1 and 42 sixtieths. We're going to focus on that 42 sixtieths. What is 42 sixtieths as a decimal? Many hands are typing into their calculator. If they're not typing into their calculator, their hands are raised because they already know what it is as a decimal. It's right here. And now that we've typed it into our calculators, 1 and 42 sixtieths changed to a decimal is, thank you for the hands, Maston, 1.7. 1 whole, right? We still have our 1 whole. Here's our 1 whole. That 42 sixtieths simplifies to 0.7. So now, what am I going to be typing into the calculator? I now know that 1 hour and 42 minutes is 1.7 hours. I'm going to write that in there, because it's confusing when I have both hours and minutes. So we've changed this to just measure in hours, 1.7 hours. But what do I do anytime I go forward in this table? What am I always doing? We already even wrote it down. What are we always doing? Alexi. We're not dividing by 550. What does that say right there? Multiplying by 550. So we should be typing into our calculator 1.7 times 550, and that's going to give us the distance from St. Louis to Albuquerque, right? Good, thank you for those hands. So many of you already typed it in so quickly. Timothy. 935 miles. You guys all get the same thing? Great. And now, every time we go forward in this table, we're multiplying by 550. But this is blank, so I can't take a blank thing and multiply by 550. That means instead I'm going to work backwards by dividing. So what should I be typing into the calculator right now? Luke, what are we typing into the calculator? Nope. Look at what we're starting with. We're starting here with our 330. There you go. 330 divided by 550, and that's going to tell us the time. Good. We'll wait until a few more students have a chance to enter that into their calculators. We're typing in 330 divided by 550. Thank you, Birdie. 0.6, you guys get the same thing? And is it just 0.6? It's not 0.6 repeating, right? It's just 0.6? All right, awesome. 0.6 what? Hours. Good. Thank you for remembering that unit of measure. That's going to help us. So we answer these questions. What is the distance between St. Louis and Albuquerque? St. Louis to Albuquerque, it was 935 miles. But let's also make sure that we're writing down how we got there. It was our 1.7 hours multiplied by 550, and that's how we got the 935. How many minutes did it take to fly between Albuquerque and Phoenix? Here's the Albuquerque and Phoenix. We know what the distance is. How many hours? It says 0.6 hours, but this question is asking how many minutes, isn't it? So we got to do some work here. So I'm going to put down that 0.6 hours. But let's make sure we actually answer the question. We're trying to go from hours to minutes. Okay, so watch what we're going to do. This decimal here, we're going to change it back into a fraction. And so that is 6 tenths, 6 in the tens place. And there's 60 minutes in an hour, right? Remember that right here? So I want to change this bottom number to a 60. How does a 10 change to be a 60? Good, I like all these hands. McGuire. Multiply by 6. So what am I doing up here? Multiplying by 6. Use your calculator if you need to. 6 times 6 is, Leah, 36. So we took our 0.6 hours and we converted that to minutes. 0.6 hours is equal to 36 minutes. What is the proportional relationship represented by this table? And again, we can say this in a lot of different ways. Basically, what we're saying is the time is proportional to the distance. The distance is proportional to the time. Distance and time is a proportional relationship. Okay, we can say it lots of different ways. What I'm going to write and what I encourage you to write is the distance is proportional to the time. And then here's the big takeaway. Again, we want to look as we go forward across this table, what are we doing? And so I want to say the time in hours times 550 is equal to the distance, because every time I go forward in this table, we're multiplying by 550. This is all about that constant of proportionality. Okay, let's back up a little bit. Let's go back up to the table. Do you see how there's this third column that we ignored? Let's go back and fill that in now, because it says speed. How do we measure speed? Does anyone know how we measure speed? Good, Brighton? That would be distance, but it still wouldn't be speed. How do we measure speed? You're missing something. Let's go Kate and S. Miles per hour. So we might say nautical miles per hour, but we still need to make sure that we're relating the distance to the time. So the speed is going to be in miles per hour. So let's calculate the speed. Well, this one's going to be easy. 550 miles per 1 hour. Let's focus, please. And guess what? This is our unit rate. 550 miles over 1 hour. So the speed is 550 miles per hour. We're lazy and we just say mph. You probably have seen that on speed limit signs, mph. Let's calculate the next one. Miles per hour, that's going to be 935 miles and 1.7 hours. So 935 miles over 1.7 hours. And we have one more here. Once we get them all written down, I'll have you guys start typing them into your calculator. 330 miles and 0.6 hours. All right, you've got some things to type into your calculator now. What is 935 divided by 1.7? What's the miles per hour here? What's 330 divided by 0.6? What's the miles per hour here? Give you a few seconds to type those in. Check in with your group. Make sure that all of you are on the same page doing these calculations correctly. So hands down because we're checking in with our groups. We'll come back together in about 30 seconds once you've had a chance to calculate these. What does it say? It says 935. What does this say right here? This says divide. 935 divide by 1.7. Okay, your time is up. I didn't hear a whole lot of group work. Nobody really checked in with their group too noisily. Tell me, Porter, what is 935 miles in 1.7 hours? What is the speed? 550 miles per hour, same as above? Okay. And tell me what 330 miles in 0.6 hours is, Gabe. 550 again? Does this make sense that the speed is going to be exactly the same? It does, because guess what? It says right up here, a plane traveling at a constant speed. Does that number 550, does that seem familiar to you at all? Have we seen that number 550 before? Where did we see it? The constant of proportionality. Good, that constant of proportionality. So here's something that I want you to connect. This is the unit rate. That speed was the unit rate. But that unit rate was equal to the constant of proportionality. They're the same. Let's focus, please. The unit rate is the same as the constant of proportionality. And now we're going to redo this problem again, because when we look at number 4, it says, Diego says the constant of proportionality is 550. That sounds right. That's what we found too. But it says Andre says the constant of proportionality is 9 1/6. So obviously Andre is wrong, right? He's actually not wrong. And we're going to show how he's not wrong by redoing this problem in a different way. Okay? This time, instead of using this column to measure the time in hours, we're going to use it to measure the time in minutes. And that's going to change things just a little bit. Okay? So 1 hour measured in minutes is going to be what? How many minutes in an hour? 60 minutes. So we're not going to use the number 1 anymore because we're not going to look at hours. We're going to look at minutes. So I'm going to put here 60 minutes. Got it? All right, now here's what you're going to talk with your groups. 1 hour, 42 minutes. I need to know what is that number in just minutes. Talk to your group members. Ready, set, go. One hour, 42 minutes is how many minutes? What do you got for me? Let's go, Luke. It is 102 minutes. Good. How did you get that? Good. The hour is 60 minutes plus an extra 42 minutes, so that's how I got the 102 minutes. So again, I'm not going to use this information anymore. We used it to figure out minutes, and now this is the number that I'm looking for. And now it's a little bit harder. How do we go forward? Do you know what that number is that we're multiplying by now? It's not 550 anymore, is it? What's 60 times 550? Does it give you 550? So can I take that 60 and multiply it by 550 and get 550? No. So what do I need to do? We need to figure out what number we're multiplying by. You're going to work with your groups on that right now. What are we multiplying by? Use your calculators. You have 30 seconds before we come back together. Go. Okay. What are we multiplying by as we go across this table? Thank you for the hands. Brighton? And you know that because you already looked at the answer here. But if the answer isn't going to be given to you, P.S., it's not going to be given to you on your homework. How are you going to find this? Leah? Exactly. Eyes on the screen. If this weren't here for you, you wouldn't know what to multiply by. And since we don't know what to multiply by, we have to go backwards and divide. So let's go backwards. That's going to be 550 divided by 60. And 550 divided by 60, this is how I know you guys didn't actually do the work and you just use the information on the paper. Because when you actually do 550 divided by 60, what do you get? Thank you, Jerem. Which is 9.16 over bar. That 7 isn't really there. It's a repeating decimal. But before it was a decimal, what is it as a fraction? Because I like fractions. Fractions are friends. Gabe? Say that again. 55/6. So what are we doing as we go forward in this table? We're going to multiply by, I'm going to give you a hint. If you multiply by this number here, your calculator doesn't like it too much because it doesn't handle those repeating decimals very well. It's better if you multiply it by the fraction 55/6. So we're going to put multiply by 55/6. Do that for me just to make sure that it works. Here it is in our calculator. We're going to go 60 times the fraction 55/6. I'm really hoping this gives me 550. Do you think it's going to work? Yep, it did. When you use your calculator the right way, it'll give you 550. So that confirms that I went backwards, 550 divided by 60, and I got this number. And I used that number to go forwards, and it definitely works. So what am I going to be multiplying by here in the table? What am I going to be multiplying by here in the table? Talk with your groups then, because there should be more hands on this. Now let's see those hands again, now that you've had a chance to get your brain power from your group. What am I multiplying by here, Alex? You're close. We would say that 55/6. So what am I typing in here? 102 times 55/6. And I hope that we're getting, what did we get before? 935? Are we getting 935 again? That's a good thing. It's a good sign. Because the miles isn't changing. The only thing that's changing is that instead of measuring it in hours, we're now measuring it in minutes. And that means if I wanted to go backwards in this table, I would need to divide by 55/6. So go ahead and type that one into your calculator. That's going to look like this. 330 divided by, now here's where it gets to be tricky. I'm dividing by a fraction, so we need to make sure we're careful on how we're entering this. 330 divided by, and then I got the fraction. And the fraction is 55/6. Enter it into your calculator, and we'll see how you did. I'm not going to have my answer up there. Good, thank you for these hands. Aiden, you are absolutely correct. 36 minutes, which is exactly what we had before. Sure, up here it said 0.6 hours, but we did that work that 0.6 hours is 36 minutes. So we filled it out two ways, right? One way, we saw that the constant of proportionality was 550. Andre says that the constant proportionality is 9 1/6. Where is that 9 1/6 coming from? Well, 9 1/6 is the same as 55/6. And if you don't understand that connection, that is actually not something that I will be going over. That is, probably 4th and 5th grade, 6th grade material. converting from mixed numbers to improper fractions. So 55/6. So both of them are correct. They just use different units of measure. Diego used hours and Andre used minutes. And now, ladies and gentlemen, it is time to summarize. Just for the sake of time, I'm not going to go over the speed on these ones. The speed is normally miles per hour, but because we did this time in minutes, this would be miles per minute, which you can do, but for the sake of time, I'm going to skip it. So let's look at our summary. When something is traveling at a constant speed, like that plane in that last problem, there is a proportional relationship between the time it takes and the distance traveled. This table shows the distance traveled and elapsed for a bug crawling on a sidewalk. 3/2 times some number is 1. You want to know what that number is? Look here. This is always the easiest place to find it. How does a 1 change to a 2/3? Well, we must be multiplying by 2/3. That 1 is really helpful because that 1 is the unit rate. We can multiply any number in the first column by 2/3 to get the corresponding number in the second column. So we can say that the elapsed time is proportional to the distance traveled, and the constant of proportionality is 2/3 because I'm multiplying by 2/3 as I go forward. That also tells us that the bug's pace is 2/3 of a second per centimeter. That there is the unit rate. But now compare it to this table below, and you're going to see we've got the same information, but the table, the columns, are reversed. You want to know what we're multiplying by? Find the 1. How does a 1 change to 3/2? We must be multiplying by 3/2. So 2/3 multiplied by 3/2 is 1, 2 multiplied by 3/2 is 3, and so on. But again, the place to look is where the 1 is. We can multiply any number in this first column by 3/2 to get the corresponding number in the second column. So we can say that the distance traveled is proportional to the elapsed time, and the constant of proportionality this time is 3/2. This means that the bug's speed is 3/2 of a centimeter per second. That is, once again, the unit rate. Notice that the unit rate, 3/2, and the constant of proportionality, 3/2, they are the same. I also want you to notice the relationship between these two constants of proportionality. Going forward, we multiplied by 2/3, but when I switch those columns, now I'm multiplying by 3/2. There's a word for that. We talked about that last time, and at the brief review, these are reciprocals. And whenever we switch those columns, they're always going to be reciprocals. Let's finish up with our cool down. For the sake of time, I'm going to work on this with you. I will give you just 30 seconds, and in those 30 seconds, I want you to figure out what are we multiplying by. Use your calculators, talk with your groups, 30 seconds, and then we're going to go over it together. Ready, set, go. Okay, that was your 30 seconds. That's time. What are we multiplying by? Anyone know off the top of their head how a 0.5 goes to a 0.8? Nobody off the top of your head? And no one knows off the top of their head. So since we don't know how to go forward, what's our strategy? What do? We, Emily, go backwards. Since we don't know how to go forwards, go backwards. That means we should be dividing. So what I should have typed into my calculator is 0.8 divided by 0.5. And what did you get when you did that? Thank you for these hands. Who have I not called on yet today? Let's go, Emily. 1.6. Agree or disagree? Agree. Great. So I know that I'm multiplying by 1.6. So when there's 1 minute here, all I have to do is multiply it by 1.6 and I get 1.6. That's the easy one. And here I'm still going to multiply by 1.6, and 3 times 1.6 is equal to, quick hands, Birdie, 4.8. And now I have to go backwards in this table, so that means I'm going to divide by 1.6. 40 divided by 1.6, Kate and S? 25. Agree or disagree? Okay, I haven't actually calculated, so thank you. And now let's answer, because we already answered these questions here by filling out the table. What is the constant of proportionality? I want to see every hand for this one, so if you need a little bit of extra think time, that's fine. What is the constant of proportionality here? What is the constant of proportionality? Lance. It is 1.6, because what is it that I'm multiplying by everywhere on that table? 1.6 as we go across. So the constant of proportionality is 1.6. Real quick, how many gallons of water will be in the fish tank after 3 minutes? That would be 4.8 gallons. How long will it take for 40 gallons to finally fill the tank? That'll be 25 minutes. And that's it for today. Your homework is the Lesson 3 practice problems. That's it for today. We'll see you next time.